Hey guys, I want to show you this algebra review of, it's primarily like Algebra 1, right? So, and I guess everything in this review is covered on my channel if you're interested in looking at anything else in there. Okay, cool. So some of it, the first part is just like fill in the blank, but the rest of it's going to be like math. It's going to be like real math. Okay, cool. So let's go ahead and start. Okay, a set within a set is called a subset. Subset, right? So the word sub right here is here's a set and then here's a subset. Okay, a set with no members. Members is like all the stuff in it, like X, Y, 1, 2, any like stuff, just anything in it is called a null set, or I'm guessing empty set is what I'm presuming. Null I feel confident about. Empty, I'm presuming that's what the answer is. Okay, cool. Naming a set by describing its element is called the rule method. Okay. Naming a set describing its element. Yeah, it's pretty straightforward. Okay. A method of naming a set by listing its members is, that's a typo right there, is called, where am I? Roster, right? So that's kind of like, you know how like the instructor will like list all y'all's names to see if you're there or not? That's the equivalent. So think of it like when you come in the class in the morning and they take roll call, right? Roll and roster, it sounds kind of similar. Sets that are countable or stop are called finite. The wording is kind of tricky here, like the language, because they're basically saying like if any list has a stop point, if I go 1, 2, and I go all the way to 10, right? That's finite. So here's the here's the opposite. Sets that are continuing forever, right? They go forever, or are uncountable and are called infinite. This word is going to come up a lot when you take calculus, right? These two words. Primarily this one, it's going to come up a lot. Let's try more stuff. Okay. It's asking true or false. Is this equal? Is this equal? Let's see. I have a bunch of numbers and then I have a bunch of alphabets or variables. It's asking about the equal sign. This is false. So the reason it's false is because there's an equal sign. That means it has to look identical. It either has to be all numbers or it has to be all variables or it has to be mixed in properly and equally. So right now it's false, unless they decide to switch it up on us. Okay, this is true or false. Equivalent sets have like the same number of members, right? This is equivalent set. They have the same number of members, right? So this is a member, this is a member, this is a member. Here's one more member. A member is just like anything between the commas. So it's, this little symbol means, do you have the same number of members? Do you have the same grouping of people? If I have 3 people and they're called 2, 4, and 6, and I have 3 more people called 1, 3, and 5, then yeah, it's true. I have 3 people hanging out at this party. I got 3 people in this party. So yeah, the rooms have 3 people equally. Therefore, yeah, it's true. So this thing right here, this symbol right here, this is asking you about overlap, which means repeating stuff. So what's repeating? 2, 7, 8, 1, 3, 8. Looks like the 8 is repeating. So the answer is 8. Over here where it goes upward, it's asking about all the members in the set, right? So we're just going to see, let's do it alphabetically. I have 1, 3, 4, 1, 3, 4. 5 is repeated, so I don't need to put 5 in a million times. And 6, right? That's the answer. That's my set. Let's see. Okay, express each of the following algebraically. Cool. This is kind of tough for everybody. I also struggle with it. I'm no different, right? So we have to take it literally one word at a time. I think that helps. So we know this is going to be 4. Well, I can't even. 4 more. That means plus 4 more. Then twice a number, twice a number. What would that look like? Twice a number plus 4, right? You can even do 4 plus 2x. But when you see the word more, it's a plus. Let's see. I guess that's the final answer, both of these. Let's put a little stick down the middle. Okay, a number decreasing by 6. Okay, what would that look like? Decreasing is a minus sign. So they're telling me to do number first, a number. X decreasing by 6. That's what that looks like. A number increasing. Increasing is a plus sign. A number, when it says a number, it's like a mystery thing, so you're going to do a variable of x. A number increasing. Increasing by 10. That's what that looks like. Increasing by 10. If it feels like I'm going through all these like way too fast, yeah, that's because it's a review, so I'm trying to put a little bit of information in it, but it has to just basically just be like solving the problem, right? And then you just kind of determine if you got it right or not. Ideally, you can do it faster than me, right? So that'd be pretty cool. I take forever with these. Okay, a number decreasing by 4 times y. 4 times y, what does that look like? It's going to be x decreasing 4 times y. That's what that looks like. With these word problem things, like it helps to know like the magic code, right? Like this means add, this is subtract, this is add, this is subtract, right? If you got that down, the rest of it gets a little bit easier because those are the main pieces. The rest of it is like secondary. Okay, cool. We're going to do more problems. So I have problem 12 right here. So it's asking, let's see, what is it asking? It's asking for anywhere there's a p, you're going to replace it with 6. So let's go ahead and do that. I guess I'll just do like a spacing. I think that's too big, maybe. Okay. I'm going to put a 6 in there and a 6 in there. Great. Okay. And then the thing is, like, sometimes with these, sometimes it doesn't matter. But if you're never sure, right, we're going to try to apply that if we're never sure. This one's pretty straightforward. So 6 square is going to be 36. Let me rewrite this. I feel like my hand is not really functioning here. All right, sweet. Okay. So we have 36 plus, that's going to be 42 minus 5, right? We're going to go ahead and add these together, making it 78 minus 5, which gives me 73. Cool. That's the answer for 12. What about 13? We're going to evaluate this number if x is 2, y is 3, and z is 4. Okay, there's a lot of stuff going on. So let's go ahead and try doing that. 4. Let's put a gap there. Let's put a gap there, and then another one. So we have x, y, and z. X, y, z. Okay, let's see. So we're going to put that into this, into that, into that. So we have 4. That makes 4. And then 3 and 3 is 27. And then 4 squared is 16. Right? Let's go ahead and distribute that. So it's 16, 27, 16. Let me get my calculator because I'm going to need it. 16, 27, 16. Cool. I have 6912. That's my answer. Great. Perfect. All we did is just plug things in. Oh, okay. Here's some fractions. Okay. We're going to take this entire thing and we're going to replace all the alphabets with the numbers. What does that look like? We're going to do 3 times 4 over 4 minus 3 plus 4, 6. Oh, and there's a z, 6. Let's see. So 3 and 4 is 12 over 4 minus 12, 27? 27. Let me confirm with my calculator. Times 6. Yeah, cool, it's 27 and 6, right? So that's what we got for this guy, and that's what we got for this guy. Okay. So now, here's the thing. I have to make sure the bottom numbers are the same, right? So I'm going to 3. Let's do 3. Let's multiply by 3. And then we're going to multiply by 2. Right? So what does that give me? It gives me 36. And then this is 12. 754. 12. 18. 18. That's 12. So if we were to reduce this, it would be negative 9, 6, which again becomes negative 3 over 2. This is the final answer. So we had to plug everything in, and then I had to find the same denominator, right? And that's how we came up with this answer. I have a whole video on this topic, number 14. Wonder what that is. Oh, okay, must be a typo. Or maybe not. Who knows? Okay, 15. Let's solve for x. Oh, okay, this is pretty straightforward. We're rewriting it. We're solving for x. So what we're doing is we're going to get x by itself. How do I do that? I'm going to do negative 18 on both sides, right? Because we're trying to push everything over to the equal sign. That gives me a 0. So I have x equals 64 minus 18. Right, we're going to do a 5 here, 14 here. It gives me 46. X equals 46. That's my final answer. What about 16? Solve for x again. I have 4x. Is that a minus? Minus 8 equals 32. Okay, so same idea, except there's one more step, right? So what do we do? It's going to be, well, let's leave that. Okay, we're going to do plus 8, 4x, 8, 10, 40. Okay, and then I'm going to have to get x by itself. How do I do that? Well, I'm going to divide it by 4. X equals 10. Great. Perfect. What about this one right here? Solve for y. Let me rewrite it. I have y 8 minus 3 equals 9. Okay, that's tricky. There's a fraction, right? It kind of looks intimidating, but we can get through it. Let's see. So my goal is to get y by itself. How do I do that? Well, I'm going to get rid of 8. And I have to move it here. Right? So that goes away. So I have y minus 3 equals 6, 7. Is it 72? Am I doing this right? Let me try this again. I'm going to move the 3 over first. I guess, I don't know. Plus 3, right? So that gives us a 0. That's a 12. Okay, so now I have to get y by itself, which we're applying the same method, which is like that 8 over 1 to get rid of it. And then 12 and 8, 12 times 8 is 96. I feel like I made it more challenging because I erased it and I redid the problem. Okay, yeah, 96. Okay, great. Let's do number 18 next. Solve for z. Okay, so let me rewrite it. Plus 4 equals equals 13. Okay, it's positive 13. Okay, let's go ahead and remove the 4, right? The goal is to get everything on one side. And the ultimate goal is to get z by itself, but we do that step by step by getting everything on one side of that equal sign. So that's a 0, right? So we're going to bring the 2 and the 5, z, down, which is 9. 9, and yeah, it's 9. Cool. So now I got to get that z by itself. Maybe if I do 5 over 2, right? So it gives me z equals 9 times 5, which is, oh wait, I have to do 9 and 5 is 45. And then the 2. I just multiplied these two together, and there's an invisible one here, and I multiplied these two together. I don't see myself reducing it further. So this is the final answer. Okay, cool. Let's go move on to number 19. There's quite a few of these. Let's see. Solve for x. There's 2 of them. Okay, so this is pretty interesting. So when we have 2 of them, we're just going to mash them together. Right here. Right, so here's that equal sign right there. That becomes 0. That becomes 3x. Right, 7 minus 4 is 3x equals negative 9. Right? So now we only have 1x. And then we just follow the same method we've been following, which is just divide by that 3. Keep the negative. Right? 3 goes into 9 3 times. That's the final answer. What about number 20? We're going to solve for n. Same concept, it's just thrown an n into the mix instead of x. Right, so let me rewrite it. And we apply the same concept. I'm trying to mash the n's together because I only need 1. Right, so 2n plus 7 equals negative 9. We're going to do negative 7 here. 2n equals negative 16. And I want to divide these by 2 so I can get that n by itself. Negative, I'm going to bring that down. 8, right? 16 and 2 is 8. That's our final answer. Let's do number 21. Let's see. Solve for y. Negative y and 6 equals 14. Okay, so I need to get the 6 out of here. So remember, when you have a fraction, you can only remove the bottom part. You can't just remove the top, right? So, and there's a video I have about that. That goes away. And then I have 84. Okay, cool. And then I have to get y by itself. So the thing is, like, it has to be a positive y because it's asking me for positive. It didn't say solve for negative y, right? It's saying y. That means I got to get y to be positive. There's an invisible little 1 right here. It literally looks like that. So all I do is just get rid of that negative 1. It gives me negative 84. That's the final answer. This right here, if you were to turn that in, that would be incorrect, right? Because you got to move that guy over. That's why this is the final answer. There's not 2 right answers. It's just 1, and it's this one. Number 22 is the same idea, except it's all variables, right? So this is just asking for procedure. I'm not satisfied with my handwriting today. My minus n equals x. At least I hope I'm seeing that's what I'm seeing. I don't know. Okay, cool. And we're going to solve for y, so we're going to get that by itself. Let's get n over with a positive n. And we have my equals x plus n, right? And then I have to divide by m, right? It's the same thing we've been doing. So I have x plus n over m. It's just, instead of numbers, instead of math, it's just variables. That's the answer. Great. Solve for m. M over n equals, is that an A? Yeah, that's an A. Cool. Okay, we're going to get m by itself. How do I do that? Let's see. It's the same idea we've been working on earlier. I'm going to move n over, right? I can't move a over. There's no point because my goal is to get m by itself. A, n. Right. I just knocked off the 1, just got rid of it. Anytime there's a little invisible 1 in the bottom, you don't need to present it. There you go. That's the final answer. Let's try another problem. Number 24. It's a lot of these. Okay. Here's a great one. Rx equals s over t. It's asking me to find x, to get x by itself. Well, here's the thing. I can't just do like one of these. This is not allowed, right? Because I can't just rip the top off. I can only rip the bottom off. I have a video about that. I think I already said that earlier. So what I got to do is I just got to throw the x on the right side and then move everything else over. So let's do that. So that goes away. I have r equals sx over t. And then I have to get everything else over. Right? So let's do t over s. T over s. Those get knocked out. So I have t. I guess I have r and t. S equals x. Right? I just put those together and then I put the s together. I alphabetized them. That's why I threw the r up front. Okay. There we go. The handwriting's wonky. I had to get a surgery on my wrist a few years ago, and I lost some motor skills, I guess. All right, cool. So we're going to solve for x. X is to y as z is to a. Right. Okay. So when it says is to, this is to, that's code for fraction. Fraction. See, that's how they get you. So it's saying x is to y, right, as, that's equal, as z is to a. That's what they're saying. That's the setup. And we're solving for x. We're just getting this by itself. Okay, cool. So how do I do that? Y over 1, right? Y over 1. X equals y z over a. That's the answer. I just alphabetized it. Cool. The word problems, like, you just have to learn how to decode it. If you see as is, it means fraction. If you see just as by itself, wait, did I say as is? I meant to say is to. Yeah, so there's like different ones, like more is plus, like we discussed earlier. So if you're eligible to bring a cheat sheet with you to class, I would have like an applications section or like a word problem section where all the secret language is decoded, so you know what like I don't know, I guess what operator to use. And the operators are like these guys right here, right? Even an equal sign can be one. So these guys, like once you kind of get an understanding, the rest of it kind of falls in place. Like we already knew X and Y, we already know what Z and A is, but this is to stuff, you know, like it falls into one of these, as falls into one of these. Cool. So let's move on to the next guy. We're going to solve for X equals half, right? So I have to get X by itself, so I'm going to get rid of the 6. 6 over 2. So how many times does 6 go into 2? I mean 2 go into 6, it goes in 3 times. This is my final answer right here for number 26. Number 27 is solve for C, which is right here. 7 over 2 equals 12 over C. And with this, I'm not allowed to do that. That's not allowed. Because we can't pull from the top. We have to start from the base. Think of it like a really big giant like cup of like hot coffee. In order to make sure the coffee doesn't spill, you hold it like towards the bottom. You hold it towards the base. You never hold it from the top because it'll burn your fingers. When you walk, it's going to like splash around. You're going to burn your fingers a little bit. So you never hold it from the top. You always hold it from the bottom. So it's the same idea here, right? So I can pull from the bottom. I cannot pull from the top. What does that mean? Well, I have to move C over. Even though C is like the center focus, I'm still able to move stuff over, even if it's like the star of the show. And then I work backwards in a way. So I got rid of C. So what does that look like? It's going to be 7C over 2 equals 12. Okay, but I still have to get C by itself. So what do? Well, I'm going to flip these guys 2 over 7. What does that give me? We get rid of that. It gives me C equals 24 over 7. I just put these together, I multiplied these together, and I multiplied that invisible one. This is my final answer. It's 24 over 7. I can't further like do anything with that, so it's just going to be as is. Okay, let's try the next problem. For the system of, okay, so this is like a system of equations problem. And all it means is you pick one of them and you throw it into the other, right? That's all it means. So how do we do that? What does that exactly mean? I have a video on it, but basically you're going to pick one, you're going to isolate one of the alphabets, the variables, and whatever is left, you're going to throw it into the second problem, right? So let's try to isolate this guy, the top one. I'm going to isolate X. So I'm going to get, let me look at my notes. I think that's supposed to be an equal sign, not a minus sign. So it's already isolated. So we can skip that step. So let me get rid of that. That's a typo, sorry y'all. To my one listener. So let's see. So we're going to take this guy and we're going to throw it into that x right there. Right? So what does that look like? Well, it's going to look like this. 3, 2y minus 8 plus 2y equals 4. That's what that looks like. And then I'm going to go ahead and distribute this 3, which is going to be 24y, 16, 8. Yeah, it's 24. 8 times 3. Let me get my calculator. Yeah, it's 24. I don't know. Can't really do math today. Evidently. Okay. 6. That doesn't get a y. This gets a y, right? I flipped it. I got too involved with the 8. Plus 2y equals 4. Great. So we're going to go ahead and combine. Should I combine? Let's try to isolate. Let's put the 4. Let's get rid of the 24. So I have 6y plus 2y gives me 20. And then I have these, which is 8 y equals 20. Get rid of that, which is y. I have, let's see, I have negative 10 and 4, which can also reduce to negative 5 and 2. So that's y, right? So we have the answer for y, but I still need x. So we figured out y, but we still need x. So let's see. Let's take this, which is x equals 2y minus 8, and we're going to throw this answer that we got into it. Negative 5, 2 minus 8. There's going to be an invisible 1 underneath. What does that look like? We're going to put these together. We're going to put these together. Negative 10 over 2 minus 8. Right? So, that would give me 5 minus 8, which gives me negative 5 minus 8, which gives me x is 3. Right there. Right, so x is 3, y is negative 5 over 2. That's my answer, because it's asking me for 2 answers. It's asking for x and y. That's my final answer. Let's do the next problem. 28, so we should have 29 next. Great. It's another system of equations. Cool. Let me see. I guess should we name these? It's already A and B. Okay, maybe we shouldn't name them. Okay, so we're going to do the first one. I feel like these are wrong. I mean, I don't want to end up with a bunch of fractions. Hold on. Let me see. Okay. I changed one of the terms because we're going to get fractions. And I was hoping for like whole numbers so we can streamline through it easier. Although it might take a long time, but let's see. This is a review I found in a book from like the 80s. So I already completed the review. I'm just going back in the book and looking. to see if I got it right, but we had a typo right here. We had a typo. I don't know if that's significant or worth mentioning. Anyways, okay. So we're going to isolate maybe the a from the first one right here. So I have 3a plus 2b equals 1. And let's see, we're going to get 3a equals negative 2b plus 1 over 3. I did it in one swoop. I don't know if that's appropriate, but that's what I got, right? So I'm going to take the second guy, and I'm going to take my answer of A, and I'm going to insert it into it. So I have 2 negative 2b plus 1 over 3 minus 3b equals negative 8. Great. So now I'm going to distributes the 2 into the numerator only, right? Because there's an invisible 1. So we're not going to put it in the bottom one. We're just going to do it in the top one. Gives me negative 4b plus 2 over 3 minus 3b equals negative 8, right? And what I'm trying to do is I'm going to move this over, right? I want to move this over and get it onto the other side. Move this whole thing over, right? So the reason I was able to do that is because I did 4b plus 2, and I gave the denominator repeated twice. I give the numerator, I guess, its own denominator. And therefore, I was able to remove this with a negative sign. So because it's a plus sign, I did negative. I did not just flip it and then move it over like I've been doing earlier in the review, because adding and subtracting go together, multiplying, dividing go together. So I did not flip it. I simply subtracted, right? So what does it give me? Negative 4b over 3 negative 8 minus 2 over 3. So that's going to get a 1, right? So I want to make sure everything gets a negative, a minus, no, not minus, a 1. Great. So here's the thing. All the denominators have to be the same. So I have to add a 3 to this. So what does that look like? This guy and this guy stay exactly the same. (24 over 3, 2, 3). Great. Do you see how the denominators are the same? Great. So now we can put these together, and we can put these together. Negative 13b over 3 equals negative 26 over 3. Great. Now I need to get b by itself, right? Because that's the whole point of the show, is to get a and b by itself while still using these equations. Let's do 3, negative 13. 3, negative 13. I just flipped it over. 79. Wait, let me see. 26 times 3. It's 78. Okay. It's almost there, but not quite there. Right? 39. It's going to be positive because we have two negatives. Right? And 70, it looks like 79 divided, yeah. Great. I thought it was a whole number. It looks like a whole number. So that becomes 2. It goes in twice. Right? So that's B. B equals 2. That's a whole number, right? So that's one of our answers. Now we got to figure out A. So let's go all the way up here, and we're going to apply it to the first one. 3A plus 2B equals 1. Right here, the first one. I'm going to distribute. Plus 4 is 1. I got to do 3A minus 4, right? Minus 4 on both sides gives me negative 3. And I have to divide. It's going to be 1, but I got to bring that down, so it's going to be negative. There we go. So the answer is A is negative 1 and B is positive 2. Those are my final answers. I'm going to have 2 answers. There was a typo. Had I not identified that typo, we would have had like all these different fractions. And I wanted to show you, we can do something elaborate and still end up with a whole number. That's why I picked that particular problem. But it looked off. I did the review already, like, I don't know, a couple of days ago. Something, maybe more. Maybe it was more than a couple of days ago. Okay, sweet. So the next one is going to be 30. 29. 30. Okay, there's no 30. All right, here we go. So we're going to do 31 instead, I guess. Let's see. Well, you know, my cat stepped on the laptop. I wonder if she deleted the slide I was working on. Okay, so maybe the cat deleted it when she was jumping on the laptop. So, okay, cool. Let's just move on. It's probably another systems of equation problem, most likely. Okay, so we're just going to go ahead and subtract, because that's what it's asking us to do. But the variables, the alphabets are the same. So we get to keep those as is. So that's pretty easy. We're just doing 12 minus 15, which is 3, with a negative in front. That's it. That's a final answer. It's pretty straightforward. 32. Let's see. QT squared. QT squared. Okay, let's put these together. Right, that gives us 4QT squared plus 6QT squared. And that gives us 10 QT squared. That's the final answer. Hooray. What about the next one, which is 33? We're going to simplify. We have 3 of these, we have 2 of these, we have 1 of these. So what does that look like? Well, if you remember, A, N, M is going to be A, N plus M. Right? So these are little invisible ones back behind here. So what does that mean? I have 3 of them. So I'm going to do A, 1 plus 1 plus 1, X, 1 plus 1, and then Y is 1. Which is A, 3, X, 2, Y, 1. It can also be A, 3, X, 2, Y. And we leave that 1 out. These are both correct. right? And a lot of my videos talk about that little formula right there, if it's kind of like new idea to you. Okay, cool. 34. We're going to simplify. There's a lot of stuff going on there. Let me see if I can see that. Oh, I see. Okay, cool. All we're doing is simplifying, which means we're just pushing everything together. So let's look for repeating patterns. I only have one x, one y, one z, but I have two of these guys, these coefficients, or maybe even a constant. So what do I have? Let's put the 6's together. I mean, the 3 and the 2 together, thus making 6. And I have a x, and then I have a y, and then I have a z. This is actually my final answer. Yeah, okay, cool. I jumped the pew-pew with that one. Okay, let's try another one. Number 35. Let's see. This is the same concept, right? A n times m is a plus n plus m. So we have y 3 plus 5 equals y 8. That's the final answer. That's exciting. It's pretty straightforward. Let's see. Let's try this one. We can push it together. We have a squared plus 3, and then we have times b 1 plus 4. And that's the same formula we use, which is a n times m equals a n plus m. This one's really important. You know, you're going to see it so much in calculus. I saw it a lot in algebra, but man, calculus, it was slammed into you in calculus, like calculus 1, 2, and 3. So what does that give me? It gives me 5, and then b is also 5. There we go. I can't simplify it any further. It feels like it, right, because there's so many 5s, but we can't simplify it any further. Let's try more stuff. So at 37, we're multiplying. And remember that when you have these exponents being multiplied together, what we're going to do is we're going to add them together, right? So what do we have? We have the 2 and the 3, which is going to be negative 6. And then I have x2 plus 3. And then I have y 1 plus 4. And what does that give me? It gives me negative 6, x plus 5, y plus 5. It's kind of similar to our previous question we completed a moment ago. Great. Let's see. 38, similar in nature. Let's see. Oh, here it is. We're going to distribute. Is that a 3? 3, and then n is 3, negative 2, m 4, n squared. Okay. So then I'm going to put these coefficients together, giving me a positive 6. M. And then n is going to be right here. That's a 5. I don't know if you can see that. The tail is not established. Okay. Sweet. That's the answer. Hooray. Okay, let's try another one. Let's see. There's an invisible 1 right here. So 1 times 4 is 4. A is going to be, looks like it's just a 2. And then B is 3 plus 3. Oh, wait. C is 3 plus 2. And then I have a D as well, which is a 1. 2, 6. That's a 5. And then that's a 1. That's our answer. Great. Let's do another one. Number 40 is set up with the formula A n m equals A n times m, right? Do you notice there's two formulas? There's this one that I'm circling at the very top, and then there's this one, right? So you have to look at the way it's set up. So we're not using the top one, we're using this bottom one down here. What does that look like? Well, it looks like a 7 times 4. That's supposed to be an a. 7 times 4, which is 28. So what does that give me? Oh, I guess that's an x anyways. Man, I'm not doing well today. Okay, let's do that again. That's an x, right? That's an x right here. So then what was 7? 4, which gives me x. That's 28, 28, 28. Right? Okay, cool. That's the final answer. So, I use both of these formulas pretty frequently. I guess, yeah, I don't think one is more used than the other, in my experience, right, which is anecdotal. So 41, let's try this one. Well, this is an interesting one. Okay, so we have this formula we're applying here. So we have a, 2, and 3. And then we have b, 3 times 3, right? Because we're using this formula right here. Which gives me a and 6. 2 times 3 is 6. And then I have b, 3 times 3 is 9. This is my final answer. 42, same concept, same idea, except I'm going to put it into the coefficient, the number up front, and we're also applying it to the other guys. So it looks like this. 3 times 2, and then I have y 5 times 2, right? So this is 9, this is 6, this is 10. That's our answer. Hooray. Let's try more problems. So 42, so we should move on to 43. Let's see. Okay, this is a good one. This always reminds me of my calculus professor. The number of times, I even got this wrong on an exam. When you see this minus sign and you're seeing exponents, we're going to subtract. This has been like traumatized, grilled into my head, right? So it's going to be x 5 minus 2, right? We're just taking these guys because the base is the same, right? So let's do n divided by xm, same base, the base is that x. You're going to end up with something called xn minus m. That's the formula. So that's the thing. There's just like little tiny baby formulas that are pretty straightforward and like easy. You just kind of have to remember them. So that's like the tricky part. If you could just remember them or have like a cheat sheet like with you, it makes the stuff super easy. Or you can have traumatic experiences like I did. So let's see. That's 5 minus 2 is 3. There you go. That's it. That's the final answer. Great. So here's some more that are similar in nature, right? We have a division. Okay, here's the thing. You have a division. This is a division. And then you have an exponent. We're going to use a subtraction rule right here. This whole thing we just built. I'm going to use it here for number 44. What does that look like? Well, it's going to look like a 6 minus 4. And it's going to look like b 2 minus 1. There's an invisible little baby 1 right here. What does that give me? Okay, it gives me a 2. 6 minus 4 is 2. And then we get a b of 1. That's my final answer. Let's do number 45. This one is the same idea, except we also got to work with these coefficients here. Got to make sure those get worked out, which is 7, right? 14 divided by 2 is 7. 2 goes into 14 7 times. And then I have x 6 minus 1, and then that is y 4 minus 1, I think is what I'm looking at. The font is really small. X, that's 5, and then y is 3. Final answer. Great. Looks like 46 is moving us over? No, that's also division. Never mind. I thought it was addition. It's also division, so we're still doing the same thing. Let's do that. So this one's pretty interesting because it's not 15 divided by 3. It's 3 divided by 15, right? So let's rewrite it. Oh, geez. Let's rewrite it in a way that is useful to us. 3p6 q4 over 15p4 q8. Well, how many times does 3 go into 15? It goes in 5 times. And then we have p right here, 6 and 4. Well, the bigger one is at the numerator, the top number, so that's going to be p2, right? And then what about this bottom part? It's not going to be 4 and 8, right? You don't need to do that. That's not correct. You just find the bigger number, which is at the bottom right here. And we're going to go ahead and do q. And then it's going to be 4. Because 8 minus 4, right? I don't think I did a problem like this in my on my channel. So I don't know how thorough I was with this explanation. Okay, this is number 47. Looks like we left that part out. Okay. Let's see. So this one is already lined up for us. So all we're doing is we're finding the same base. So these are the same base. This is the same base, and then this is the same base. So when we have the same base, we just keep it exactly as it is, and we're just messing with the numbers up front. So this is like an invisible one right here. So this is going to be 4x squared plus 1 plus 5 is 6xy plus, let's see, 2 and 3 is 5y, and then we have a squared. That's it. That's the final answer. I can't simplify further because I don't have an x in all 3 terms, and I don't have a y in all 3 terms. And the coefficients, the numbers up front, the 4, 6, 5, those also, I can't really pull anything out evenly. Although, it feels like you can, right? I mean, I'm not seeing anything instinctually or immediately. Cool, let's do more. This is a plus sign. So let's go ahead and do that again. Don't be shy about stacking these. Okay, great. So it's 3 and 6. It's 9x. And then we have 7 minus 2. That gives us a 5. It's a positive 5. We know it's positive because that 7 is positive. There we go. That's the answer. All right, let's do more problems. I'm going to be honest with you guys. There's over 100 problems. So you can, you can close this out anytime you want. All right, here's a handful more. Oh, okay, I hope there's room for all these. There's a lot on this screen. Let's see. So 48. No, it's 49. 3. We're subtracting. We're just doing basic subtractions. We could stack it. Let's go and stack it. We probably have room. ST plus 13 minus 2S2 plus 2. It looks like we have the same base, right? The variables, those alphabets are the base, also called variables. Okay, so 3 minus 2 is 1. It's a little invisible 1 up there. And then we have 4 minus 2. And we have 13 minus 3. Right? We're putting that negative into that. That's the final answer. What about 50? Let's try 50. Base. Okay. 2. Okay, it looks like this is where it kind of is the focal point. 2a 7a squared minus 5ab mu. And then I got this guy here. Let me try to, okay. Sweet, okay. So 2 minus 7. Is that, wait, did I do this right? No, it's a plus. Okay, that's 9. And then 3 minus 5 is going to be 2ab squared. There you go. That's the final answer. 51 is, ooh, this is fact. Oh, wait. Let's call it FOIL. First, outer, inner, last. Right? We've done this 15 million times in our lifetime. Right, so I have 6x squared first, then outer, then inner. And then last is going to be negative 4. These guys are buddies, so we keep them together. It's going to give us positive 10. There we go. That's the final answer. Let's try another one. 52, more factoring, it feels like. Oh, okay. Let's see. 1, 2, 3. So we're going to put this A into that and then into that. And we're going to do the same thing with the middle part and the same thing with the last part. 2a squared plus ab plus 6a squared b plus 3a squared b. I'm running out of room. Plus 8a plus 4b. I don't see any repeating stuff. A, B, A. Okay, no. So this whole thing, this really long-winded thing is the final answer. Right? So I just went in and I did A, and then I went right back to the beginning and I did the same thing with the second guy and the same thing with the third guy. So I ended up with a bunch of little terms. Let's try the next one. 53. Okay. Let's go ahead and rewrite it. Is that an 8? Yeah. A7. And we're going to divide it by 2a to the third power. Okay. So 12 divided by 2 is going to be 6. And then remember, we're subtracting. 8 minus 3. And then a7 minus 3. Right, so it gives me 6. I got that from right here, right? That negative. I got A, 5, fifth power, and then I have 4 from right here, 8 and 2, A to the 4th power. That's my final answer. So what I essentially did, maybe I should rewrite a little bit of it. I have 12a, 8 minus 8a7, 2a to the third. What I did is I gave every term its own denominator. So it looks like this. See, that's what I basically ended up doing. So I messed with the numbers up front, and then this guy right here, I put a minus sign. Then I messed with the numbers up front here, and then these guys right here. And I threw it all into a box. If that makes more sense, hopefully. Okay, let's do number 54. Let's see. Okay, so it looks like there's going to be a few steps with this one. 3x2, y3. 4xy to the fourth over 2xy to the second. What does that give me? Well, it gives me positive 12 x, what is that? 3. It's going to give me 3. And then y is going to be 7, right? Because we're putting them together. A, n, m, a, n plus m. And it gives me 2xy to the second. Okay, well now I can go ahead and work on it. So I have 6, right? Because 2 and 12. Yeah, 2 and 12 gives me 6. And then 3 minus 1. 3 minus 1 is 2. And then 7 minus 2 is 5. This is my final answer. That was pretty quick. It was just 2 steps. It looks very convoluted. It looks tricky. Let's do some more problems. Division. Okay. Yeah, so this is right here. This is a factor thing. So let's go ahead and the bases are not the same. Do you see how there's like an x and a 1? So we're going to try. Let me rewrite it. Okay, so we're going to go ahead and factor out the top. I have an x here. And then I'm going to have a 1 here and like a 1 here. Yeah, and we're going to do a plus sign right here. Great. Well, because of that, we can get rid of this, we can get rid of this. So this is my final answer. Right? So if you don't have similar bases, they don't all line up perfectly, you're going to have to do this method right here, which is kind of like expanding. Well, not expanding, but like using FOIL. Yeah, so let's see. Let's do more problems. Same concept here. Looks like we're doing the same thing again. See how this exists right here? Like these line up and these line up. But this guy, you know, he's telling us that we can't just do the same thing we were doing earlier. We have to factor stuff out. Okay, let's factor. So I'm going to do 5x and then x here. They're all addition. So let's do plus 1 plus 1. X plus 1 that I got from here. Right, so we're going to get rid of these because they're alike. That's our final answer. And 57 is missing, it appears. So let's move on to 58. Okay, let's see. We're going to factor. That's what it's telling us to do. Okay, let's see. So I have 9a minus 6. Well, I mean, we could factor something out. There's something that can definitely be factored out. We can remove a 3, and that gives me 3a minus 2. I can't pull an a out because I only have one a. I need it to be in both terms. Like this is a term and this is a term. But I did find something similar, a 3. Factor completely. Okay. Let's see, what can we pull out? 3 plus 10x squared. I rewrote it. Well, I can pull out something from the coefficients, the 5 and the 10. I can pull something else out of there. And those x's, they're the same base. Those little numbers dangling at the top, the exponent, those are different, but the base, which is x, is similar. So we can definitely do something there. Let's see. Let's pull out a 5. Okay, and then what about the x? Well, we can pull out a minimum, or a maximum, rather, a maximum of 2x. I can't do 3x, and 1x is not really sufficient. Let's do 2x. What does that leave me with? Well, it's going to give me an invisible 1 right here. And it's going to leave me with x with an invisible 1, right? Because we're doing the subtraction method. What about the second part? Well, it leaves me with 2. And then there's going to be no x's because I moved all of it over. So what is the final answer? This is my final answer. Right? So I pulled something from the variables, I pulled something from the coefficients, and I also adjusted the exponents. And I did it in one step. So hopefully that's useful, right? Okay, let's do another one. We're going to factor 2 minus 9. Okay, well, when there's a subtraction, and when there's two terms with a subtraction, it's understood that one is going to be a plus sign and one is going to be a minus sign, right? So that's it, you're done. You basically just have to pay attention to this. That's it. What two numbers multiply into 9? And then the format is always going to be the variable plus mystery number next to x minus mystery number. All we have to do is focus on the last part right there. That's it. That's the formula or the setup. One is going to be subtraction, one is going to be addition. When you have two terms with a minus. Let's try this one as well. Okay, great. 61 is similar, except it's kind of backwards, right? The number that we're focusing on is right here. So it's going to be the same concept, right? So it's going to be A, because we have that here. And at the back, it's going to be B, B. And you're going to have 1 plus, 1 minus. So we just have to mess with the 36. What numbers can we use to give us 36? Well, we can use 6. 6 times 6, right? There you go. That's straight up the answer. So sometimes there's little tricks to it, right? Again, if there's two terms and you have a minus sign and it's telling you to factor, it's the same setup. You just, oh wait, wrong shape. It's the same setup. It's going to be your variable plus or minus mystery number, your variable plus or minus mystery number. Ours is a little bit backwards, but it's the same idea as number 60 and 61. They're similar in nature. Sweet, let's do another one. Looks like there's more factoring. I'm rewriting it. Okay. I'm not seeing anything instinctually, so when you don't see anything immediately, you can factor stuff out. I know it's telling us to factor, but I mean like pull something out from the front. So let's pull out a 2. That's the max we can go. Minus 16. Great. So it's going to be 2. And then here we have that whole thing where we have a variable with a mystery at the end. So it's definitely going to be A, definitely going to be plus or minus, and now we just focus on 16. Well, what two numbers can make 16? That's going to be the same number. That's 4. 4 times 4 is 16. Right? So this is straight up the final answer. What about the next one? We're going to factor. Okay, this is a basic factor, right? It's the reverse FOIL, also known as factoring, I guess. So we're going to have an x here, an x here. So we got to figure out what is going to multiply to make 2, but can also be added to make 3. Well, that seems pretty standard to me. Right? There you go. That's the final answer. I do have a video, I believe, on factoring. Gee, maybe I don't. I don't even know anymore. I don't know. I have a lot of videos. There's like 40 of them or something. Anyways, 64. Let's do the same thing again. Okay, so once an x here, an x here. So we have to find something that multiplies to 6, but also added or subtracted becomes 5. So what do I have? Well, 1 and 6, definitely, because it'll become 5. So 1, and then we could do negative, oh wait, negative 6. Yeah, plus, that's going to make a negative, and then, yeah, the 6 is bigger, right? So it's going to stay negative. Okay, that's right. That's correct. Let's see. Let's do the next one. We're going to factor. Oh, it looks like there's a 3 up front here. Okay, let's try to see. I'm definitely going to have an x. So I need to find something that's going to be equals 7, but also adds up to 20. First, let's do 3 here. That's 21. If I would do a 7, like on the outside, 3 and 7 is 21. So then we can put a 1 here. We can subtract, and then we can add. That way, the 21 becomes a 20. This is my final answer. Great. What about 66? Let's try this one next. So I think the heater just kicked on. I don't know if it's louder in the background. Let's see. So we have x. That's a 3, I hope. That's what I'm writing down. x2 plus 3x. Cool, sweet. So we're going to factor this. So there's x's in every, you know what we could do is there's x's in every single term, right? So to factor something to make it easier for ourselves, when you see like a crazy number up front like this and it's telling you to factor, try to see if what you can do is pull something out and then go ahead and do this method right here that we've been doing. One thing we can do is we could pull an x out. I could just pull one x out because the maximum I could pull out is this little 1. So let's try that. It becomes x squared minus 4x plus 3. Right? So this part right here, it looks pretty standard like we've been messing with, right? So let's go ahead and try to factor it now. Okay, I got to find something that becomes 3 when you multiply it together, but also becomes 4 when I add them together. Seems pretty straightforward that I would pick maybe 3 and 1. So there's a negative here, so we'll make them both negative. Because when you multiply 2 negatives, it becomes positive, and when you subtract these 2, it's going to give you a negative. So it satisfies what's being requested, right? If you could see that. So this, in fact, is the final answer. Even this little weird part where you just have that like x kind of thrown in there, that's chill. He's also a part of the answer. So that's pretty cool right there. Cool, sweet. Let's do another one. Okay. This is basically like backwards. It would essentially look like this, right? So, wait, 24, and then this would be a minus. No, this would be a minus. Right, that's what it would look like. Right, this would be a minus. That's what it's basically looking like. So it's just the reverses of this guy. So let's try to see what we could do. Let's keep it the direction that it provided. Right, let's not get mixed up with some kind of illegal math activities and go to math jail where they body search you. Ask me how I know. Okay, let's see. So I'm going to put the R's over here. Okay, so I got to figure out 24. What two numbers multiply 24 but add up to 10? I'm thinking 6 and 4. That's my cat, sorry guys. And then let's see, we're going to do 2 subtractions because we have a positive constant, which is that 24. The middle term is negative with that variable. Let's see. Yeah, perfect. I believe this is the answer. Great. Let's try some more problems. Let's see. Oh, it's more factoring. We have a lot of factor stuff. Let's see. Let me rewrite it. minus 2xy plus. Okay. This looks like there's a handful of constants here, so let's go ahead and try to solve it. Right, so we're just going to factor x, and then we know that y is going to go here because we have a y here. What is it, my baby? Where are you? Okay, it's my cat. Okay, and then we have the same system. We have a negative term, and then we have a positive. I might have to go check on my little froggy in a minute. Great. Okay. Perfect. That's the final answer. Okay, let's try this one here, number 69. Four and 5. Solve. Oh, it says solve. It doesn't say factor. It says solve for y. Okay, I'm glad I saw that. Okay, so we're going to do y and y here. They're both negative. So we're going to do both negative. We're solving for y. Solving for y. It's not just saying factor. If it was factoring, I would just stop like right about here. But when it says solves for y, what you do is you take everything in the parentheses and equal it to 0. Everything in the parentheses and equal it to 0. And then you isolate the y. So we're going to have a couple of them. So I have y equals positive 1. And then over here I have y equals positive 4. Right? These are my answers, both of them. So I'm going to have two answers. Both of them are the answers we need. Not just one, not just the other, but both. Now we're going to solve for x. It's the same game. We're just going to change it up a bit. Oh, this is... Let's see. So we have the thing we were talking about earlier. We're going to have to factor. There's a negative. There's two terms. So what does that mean? We're going to put two x's up front, and then we're going to have a 5 in the back because 5 and 5 make 25, plus, and then minus. That's the setup, right? And we're solving for x, so I have to isolate x. But in order for me to do that, I have to do one of these guys right here, this little setup right here, right? Because we're solving, so we have to make it equal 0. I have x equals negative 5. Oops, I forgot to put the negative in. X equals negative 5. And then I have x equals positive 5. Both of these are the answer. Great. Let's do another one. We're going to solve for x. X squared minus 5x. Great. So what does that mean? How do we do this? Well, we could factor out one of the x's. We can go in that direction. Let's try that. The max I can do is just one of them. Right? So, because the second term kind of prevents me from doing anything above that. The smallest one is the guy who gets to like play the main character, let's say. So I have x here, and then I have a 5 here. Right? So I can't factor any further. I can't factor this any further. So that means I'm going to pull this down. So it's x equals 0, and then this whole thing is going to be x minus 5 equals 0, which means x still equals 0. That's one of my answers. And then the next one is going to be x equals positive 5, because I moved it over to the other side of the equal sign, and in order for me to do that, I have to change the sign. These are the answers, 0 and 5. So when you solve for this stuff, like a way to test it, like all of these that I've done so far, like, or did so far, rather, these 4, what you're doing is you're going to take your answer and you're going to throw it in to where it's supposed to be, right? And it's supposed to equal 0. Let's see. Solve for t. Right, this one's kind of a long. Let's try to do it. Okay. 3t squared plus 21t equals 21t squared minus 3t plus 81. Sweet. Okay. So I'm going to go ahead and move everything over that is of the same base, right? So if it has the same alphabet and the same exponent. So let's move negative t squared, and that's going to be $21. Is that supposed to be a 21? Hmm. 3. I don't think this is supposed to be here. I don't think this 1 is supposed to be here. I don't want to end up with a huge, because I'm running out of room. Let's presume that there is no start over. And let's collect a black marker. Let's do that. I worked on these a few days ago, and must have been a week ago I worked on these. Well, presumably no one's even watching this at this point, so, I mean, I could do anything. So, I could just say I did it, you know, who's checking this. So I have 3x squared plus 21x equals 2x squared minus 3t. Let me check the book real quick. This is so unprofessional. Let's see. 3x squared plus 21x equals 2x squared minus 3x plus 81. Yeah. Okay, sweet. Okay, I was right. There is a typo. I erased the typo live as we're recording because that's what's up. So let's see. I want to get rid of this. Let's do a little line down here so we can keep track. I want to apply it here. And then I want to get rid of this negative t. I want to apply it here. I guess the 81 can stay. Okay, so then I have t squared, and then I have 24t. Let's do minus 81. I moved this over. T, and that's a constant. Okay. So then I have t, and then 81. It's like 9, 4, and 2. 81. 27 and, let me see, 27 and 3. 81, yeah. Let's do 27 and a 3. 24, yeah. I'm going to do a minus, positive. Yeah, okay. There we go. I hope that's right. Okay, we're going to reduce this one. Okay, so the bases are not the same, but we can still reduce. 9 and 3, we can reduce it by 9 and 12, we can reduce it by 3. So how many times does 9, how many times does 3 go into 9? It goes in 3 times. And then the same thing with the 12, it goes in 4 times. And then we're going to subtract. We're going to do x 5 minus 3. But we're going to keep it at the top because this one's bigger, right? And what I'm referencing is the exponent. The 5 is bigger than the 3. So it leaves me with 2. Remember, when you have division, you subtract. And man, did I learn that the hard way in school. Oh, there's a bunch of them now. Okay, cool. Let's go ahead and try this again. So I have 5x minus 15, 4x minus 12. There's not really anything I can do here. You know, I mean, I'm seeing some stuff with the 15 and the 12, but it wouldn't apply with the 4 and the 5. What can I do? Well, we can pull some stuff out. Let's pull a 5 out of the top one, the numerator. It's going to be x and 3. Yeah, I think this is going to work well. So then we can pull a 4 out of the bottom one. With math, it feels like it's all like step by step, you know, and if you get anything wrong, it's all wrong. Yeah, I mean, some professors are super strict, but there's a lot of flexibility in math. There's different ways of doing this, these problems. This is going to be x minus 3 as well, right? So these cross out. My answer is 5 over 4. Right? That's my answer. Let's try this one. So right from the jump, I'm most likely gonna like do some factoring stuff, right? I mean, it looks so elaborate, it's kind of intimidating, right? So let's set it up. That's my numerator at the top. That's my denominator at the bottom. So let's set it up in the numerator first. Let's see, what numbers go in? Well, I can do like a 5 and a 4 for 20. And then 9, it's a positive and then a negative. So, and then let's do the 1 for 12. So 4 and 3. 4 and 3, yeah. Let's put the 4 here. And then my 3 here. Great, perfect. We can cross these out, thus giving me this answer. Now, I can't cross these out, right? Because it's a part of like the set. Once it's in a parentheses, it's like one single number in a way. So I can't just like cross them out and say it's negative 5 over 3. It has to be that x included. So it's going to be like a little tiny like math expression on the top and then also a math expression on the bottom. It's not going to be like a constant or like one single number. Okay, let's see. Let's do some more problems before my cat comes back in the room. Okay, let's see. With this one, oh, perfect. Look, we can do stuff like across each other. Let's try that. Let's make this into a 1, and then this becomes 4. And then we can turn this into a 1, and then this into a 3. I just divided it by 3 and then divided it by 2. Right? So it gives me 4x 5, 3y to the second times y to the fourth over x to the third. 1 and 1. Yeah. Great. So let's see. We're going to do this. And then I have, you know, that formula we were looking at earlier. If it's dividing, then what we end up doing is subtracting. So if we have the same base, that a represents the base. So we're going to do 5 minus 3, which is 2. And that's going to go at the top because that 5 is bigger than the 3. And then let's get rid of those. Now we have y. I have y, 4 minus 2. And that's going to give me a 2. And it goes at the top as well. The top ones can technically float, but let's just go ahead and keep it here for the sake of, like when I mean float, it can look like this. When it's just dangling free in the air like that, it's understood that it's at the top and then there's an invisible like 1 in the bottom. So that's what it would look like. Like both of these are correct. Let's do the next one together. So right from the jump, I can tell I'm gonna have to like factor this right here. Okay, sweet. Let's go ahead and try to rewrite it. And maybe I can cross one of these guys out. I'm going to put an X up front. Okay, I got to figure something out for 6. Probably like a 6 and a 1. And let's do negative for both of them. Because this one's positive, one's negative. Right? Okay. And I'm seeing that we can get rid of that, and I can get rid of that. So it leaves me with x plus 3, x minus 6. So that's my final answer. You can also like distribute that if you wanted. It doesn't look right though, you know? I mean, that looks like there's like, I feel like if I did that, depending on my instructor, they would like be like, no, that's wrong because, you know, like they might. Let's just keep this one. I feel like all of us have been traumatized by like some math instructor somewhere out there, like all of us. Like so just whatever your instructor is, chill with. Just be compliant so you can move on, you know, to your next goal. Let's see, 4 and 9, 7 and 2. Okay, so we can't do like the cross thing like that we were doing earlier, like that. I don't have anything to. 4 and 2. Well, maybe I can take this and do something with it. Maybe like a 2x, which gives me a 2x squared. I just factored, right? So that's what I'm looking at with 7. What is that divided? By 2x over 9. And if I want the reciprocal, times 9, 2x. Right? When you do the reciprocal, you multiply and then you flip the second term. These cross out. And then you can multiply. Let's move it up over here. Oops. Let's move it up over here. So 2x, I have 2x squared times 9. I don't think there's enough room. I think I have to just solve it right here. All right, sweet. So 2x squared is going to be 18. X squared, right? That's from all of this. And then I have all of this. But keep in mind I crossed that out, so I can't use that. So it's 7 times 1, which gives me 7. I can't reduce it any further, so that's the final answer. So sometimes, I don't know, you know, sometimes you got to get very creative with it. Let's say. That one felt hard. I don't know. I mean, I feel like that one's a little bit more advanced. Maybe not, but to me it is. Like, I would categorize that. That one was kind of tricky. I don't know. Let's do the next one. So y, maybe we can extract. Yeah, maybe we can apply the same concept I did earlier with this term. I feel like we can do that. Let's go ahead and do 5. That way I get 2y plus 1. I already forgot what I wrote. Let me see. Yeah, 5. Okay, cool. 4 divided by 2y plus 1 over 2. So here's the thing. I can't just like look at both of these and go, bam, I'm going to get rid of those. It has to be like across from each other. It has to be this way or this way, making an X. How do I get there? How do I make it like that? I produce a reciprocal. or I do the reciprocal, let's say. I wonder if I could reduce 4. Yeah, okay, let's get rid of that. Let's get rid of this whole thing. So now I have, I have 5 and 2, and then I have a 4. That gives me 10 over 4. But 10 over 4 is 5 over 2. Oh, man. 5 over 2. That's my final answer. Oh my goodness. There's like no room. Oh my gosh. Okay. Sweet. Okay, number 80. Let's see. Y2. Okay. So one of the things in this book where I got these problems from, it's from like the 80s. It's from this thing called Cliff Notes, and I don't think does that company exist anymore? One of the issues was it never gave precise directions as to what to do. So like these were just the questions listed. And it didn't say like factor or add or solve or anything. It would just like be written like this. And then I had to just stare at it and guess what it wanted me to do. So right here, let me see. So the base is the same. The y's look a little bit weird, but they're the same. So it's y plus 3, y, 2y plus 5. So it's asking me to add them. So that was the tough part. Like, I guess, I don't know. I mean, was the curriculum more challenging in the past? I'm not sure, like, because it literally, maybe now in a modern textbook, I would see this problem and it would say add, it would say something like that to tell me what to do, to give me some guidelines. So the base is the same, which is the denominator. So we're just going to add it all together right here. So that would be like y plus 3 plus 2y plus 5 over y, which, let's see, we have common terms right here. So that's 3y, and we have common terms right here, which is 8. That's the final answer. 81, it's asking me to subtract. Okay, 8, 1. Let's go ahead and rewrite it. Minus 5. With the same base, we can apply the same concept we did earlier. X minus 1. 4x minus 5 minus 3x plus 6. Right? So here's the thing. This is one term. This whole thing is considered one term, or like one number. So that means I have to distribute the negative. I technically had to do it here too, this previous problem, but the thing is, when you distribute a positive with all positive, nothing changes, right? And then my denominator. So let's try that with the 5, and now my distributed negative. Let's find all the like terms. So 4 and 3 is going to be 1. And then negative 5 minus 6. I'm using a calculator. I'm getting a little bit fatigued here. So you're right, I got these together, and then I put these two together. X minus 1. There we go. 82. It's asking me to subtract. So I have 7 over x minus 6. Here, let me create a little bit. Let me rewrite it. 7x minus 6y. Okay, so here's the thing. The base is different. That means I have to make it in such a way, I have to manipulate the algebra or the numbers in such a way where the bottom numbers are exactly the same. Even if they're not real numbers and they're just like variables or alphabets, I have to make sure the alphabets in the bottom look exactly alike. And you can have a million alphabets down there. It's cool. You don't have to have just one. Okay, so what does that mean? What do I do? I'm just going to use a y here and an x here. Whatever I do downstairs, I got to do upstairs. I have a video about that. Like a video on like how to make when you're messing with fractions, how to make the bottom stuff the same. Right? So what do I end up with? It's going to be 7y xy minus 6x xy. This is the same thing. I just alphabetized it. That's why it looks like xy. You could technically keep it the same, but this version is just more sophisticated or more organized, let's say. Let's see. So now I have the same base. I'm going to do 7y minus 6x xy. Right? So I just kind of put it together. Let's see. You know, I can't go any further. I can only mess with numbers if they're exactly the same. The y and the x are different bases. So I can't add or subtract or anything. This is actually my final answer right here. Let's see. Let's do more problems. 83. It's asking me to add. So it's subtracting. So they're just asking me to add the fractions together, subtract the fractions. It's the same idea right here, right? I have almost a similar base. Almost a similar base. Do you see the bottom where it's a 4 and a 2? Okay, so I can just mess with one. I don't have to do anything to the second part, right? Because we can replicate with 2x and then get, well, wait, we don't need an x, we just need 2. We just need 2. So we can just replicate with just a constant. Okay, sweet. So, yeah, let's see, that would be 2x minus 6, right? So because I'm distributing into both, and I'm going to distribute here, which gives me 4x plus x plus 1 over 4x, right? The second part I brought down. Let's go ahead and try to factor out this guy right here. Let's do a 2. Then I have x minus 3. Oh, wait, no, we don't got to do that. We're adding. Let's try to get rid of that. Okay, so I have 2x6 plus x plus 1. Right, I just took all of these and this guy and I put them all together. The base is the same. What do I end up with? Well, 2 plus 1 is 3x. Negative 6 plus 1 is negative 5 over 4x. That's my final answer. Let me do number 84 by rewriting it, because it's very hard to see. Plus 3, that's a 6, I hope. Is that right? 84. Let me look at my book. 84, 6 and 2. Yeah, okay. Great. Let me see. So the bases are not the same. I have a 4 and a 6, and I have a 7 and a 2. So we have to create the same base. This one's just like we've been doing, where we just kind of like add something to the bottom on one side or both sides to make the bottom the same. But it looks tricky because we have to kind of pull something, right, visually. Just we don't have to pull anything actually. So if I put oh man, I have to rewrite that. Well, let I'm going to put a little bit of room between these guys. Okay. So I'm going to put an x2 here, right? So what do I know to put? How do I know to put that? An x2, how do I know to do that? Well, because of that formula that we were using. So this is the formula. So I'm putting a 2 there, right? From that 6 and that 4, there's that difference of 2. Whatever I do downstairs, I got to do upstairs. And then over here, 2, I'm going to do a 5. Right? Because there's a 7 here. And that difference between 7 and 2 is 5. Whatever I do downstairs, I got to do upstairs. Surely I have a video on this. Okay. Let's see. Okay, now I'm going to put these together, then these, then this, and then that. Right? So we should have the same bottom numbers. Right? So what does that make? It makes 7x cubed over x 6y7 plus, right there, I brought it down, plus 3y to the 5th over x 6y7. Great. Looks like that worked in our favor. So now we're going to put it all together. We're going to put this whole top with the addition together on one bar because the bottom ones are the same. Because the bottom ones are the same, we can mash it together. We only need one representative, so we're not going to repeat it twice. So here's the thing. They have different bases in the numerator, the top numbers. It's a x right here and a y right here. I can't like blend those together or do anything else. I can't factor anything out. So this actually is the final answer. It's going to look like a math problem in the top and a math problem in the bottom. 84. Let's do number 85. Let's see. 2x, x plus 1. Okay, so with this one, there's not much I can do except just like copy what's on the right onto the left, copy what's on the left onto the right. Right, so what does that look like? I'm going to do an x plus 1 here and an x plus 1 here. I'm going to do an x minus 3 here, and I'm going to do an x minus 3 here. Okay, sweet. What does that leave me with? It leaves me with 3x. Okay. 3x, x plus 1, x minus 3x plus 1, minus 2x, x minus 3, and then I'm going to say x minus 3, x plus 1. I think I'm running out of room. So let's go ahead and let's not join them. Let's do that, and we'll just bridge them together, and then we'll erase one of these. Therefore, it's the same guy, right? So we can save some space. Let's see. I guess that wasn't really valuable because I have to factor. Okay, let's distribute. So I got 3x squared plus 3x minus, right, I'm over here now, minus 2x squared minus 6. Wait. Yeah. X. Yeah, it's minus 6x. That's not positive. Minus 6x. Yeah. Plus. That's the way. Let me get rid of that. Oh man, that font is way too big. Oh boy. Okay, let's do minus 3x plus 1. Okay, so if I were to join these 3 and 2, 3 and 2, it would be x squared. And then 3 and 6 would be negative 3x. X minus 3, x plus 1. Let's factor out the x. Be x minus 3. Okay, perfect. X minus 3, x plus 1. These get crossed out. So my final answer is going to be x, right? Everything up here that I didn't cross out over everything here that I didn't cross out. X plus 1. This is my final answer. 85. So let's move on to 86 next. Okay. I guess with this one, we'd factor the denominator. But it was two different denominators, so let's go ahead and try to do that. I'm not going to rewrite it because I'm running out of room. There's not a lot of room. So this is a minus, and we mentioned when it's a minus, it gets a plus and a, oh geez, it gets a plus and a minus. And, oh no, my cat's coming here. Okay, well, she hit pause. Okay, so it's recording again. So let's see, where am I? Number 46. So we were factoring this denominator here. Actually, you know what? Let's factor the first one. I don't know why we skipped that. 16, it's 4 and 4. Okay. And then what the next one is going to be x. I guess 4 and 1 would be good here. And both addition. Great. So we're factoring. And now that we factored everything out, we have to make sure the bottom ones are the same, the denominators. So they're almost alike, you know? I mean, we got that x plus 4, but I have to, should I get a different color? So, but now I have to make sure that we include that x plus 1 and that x minus 4. Okay. Right, so what does that look like? Okay, we're going to put these two together. Oh, wait. X minus 4, x plus 1, plus 4x, x minus 4, and then I have the same 3, x plus 4, x minus 4, and then x plus 1. Alrighty. Great. So then we're going to take all of these and put it together because the denominator is the same, right? I'm going to distribute as well. So let's do x squared plus x plus 4x squared because I'm distributing minus 16x. Cool. And then my denominator, which is the same. Let's just do the placeholder of denominator. Okay, so I have the two x's, which is 5x squared. Yeah. And then I have negative 15x. And then I have x plus 4, x minus 4, x plus 1. Okay, for the sake of time, let's make this one. We can go further into it, but let's make this our final answer. Okay, and let's put this guy over here. And then number 87. So we're solving for x. So here's the thing, we got this sign right here. Just treat it like an equal. Just treat it literally like the equivalent of this right here. That's it, right? So the only time you would flip the sign is if you're dividing and multiplying with a negative. So if it's not like that, you just keep it as is. So let's try to get rid of that 2, which makes it 5x 15. I am dividing, but it's with a positive, right? So I have x, 3, right? This is my final answer. If you wanted to set it up, let me try that again. If you wanted to set it up in an official way, it's saying solve for x, that's why I put an x there, and then I'm going to put the answer itself, right? And then I'm going to close it with like a curly bracket. All right, these are both the exact same answer. One is just set up in a more traditional manner. The other, I guess, by default is informal. Just do whatever your instructor says. My instructors have typically been pretty chill about it. Except one, I guess. So, let's see. Let's try the next one. And it's when we divide, if there's a negative, we're going to flip the sign. So let's see where we get here. Okay, positive 8. So it becomes negative 4y. Well, except we're ending up with a positive again. 10, 20. Oh, wait, no, we're not. Negative 4. Y. Here's the thing, we're dividing by a negative, right? So what's the answer? It gives me a 5, but because that negative is there, we're flipping the sign. This is actually the final answer. You're not changing the answer itself, you're just changing the sign because we messed with a negative. And let's go ahead and set it up in that builder. Oh, it's Y. There, sweet. Okay. Bam, 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 bam. Okay, let's try this guy right here. I'm going to rewrite it. And we're going to go ahead and put all the variables together, all the constants together, right? So the variables are the x's, the constants are that 6 and that 2 that are just naked by itself. And then that 6 is going to be negative 6, negative 6, right? So I have 3x here. That's a 0. Let's put that there. That's a 0. And that's going to be negative 4. I am dividing, but keep in mind it's positive. So the sign stays as is. 4 over 3. That's the answer. Am I solving for x? Yeah. Oh, this is supposed to be y. Y'all, oh my gosh. Okay. Negative 4, 3. Cool. Those are the answers. Let's see. Let's move on. I'm scared my cat's going to jump on the table again. Oh, these are absolute values. These are pretty easy. They look like they're getting a little bit more elaborate as we're going. So let's see. Essentially, no matter what you put in, you're going to get a positive answer. See, no matter what you put in, you're going to get a positive answer. So the goal is to basically make it positive wherever the bars are located, right? So if there's no bars, you're not going to mess with it like that. So -9 is going to become +9. So -3 and 2 is -1, but keep in mind that it always comes out positive. -6 and 6 is going to be -12, but if it's going through the bar, it becomes positive. You know, think of it as a car wash. You know, you put your car in there, it's negative, so it's dirty, it's like a bad thing. And you take the car out after you've put it through the machine, it's clean, it's positive. Right, so -5 becomes +5 because it went through the bar. +3. It just becomes 8 because we're just messing with that. Okay, so now I have, what is that, 4 minus 8? 4 minus 8 is going to be -4. But when we put it through the car wash, it came in negative, so it's going to come out positive. Here's another one. It's going to be 9 plus 5, right? That becomes positive. What does it give me? It gives me 14. Here's another one. We have 6 minus +8. This one's kind of tricky. This one's +8. But that negative is still there, right? So what does that give me? It gives me -2. That's actually the final answer. Because the absolute value is right here and we already changed it and adjusted it as we needed. It's right here, right? So it's -2 as the final answer. Okay, it looks like we're coming towards an end here. Okay, so that's D, I think. Okay, great. So number 97 is give the coordinates of A, B, C, and D. So it looks like that's going to be 1, 2, 3 for X and 2 right here. Oh, I probably should have done that. Okay, let's do B next. It's -4. And then we go here and it's +2. Great. What about C? Where is that? Okay, it starts at 0 and it immediately drops to -2. What about D? Well, it's right here at -2. And then over here, it's at -2 again. 1, 2, oh, that's 3. Y'all, oh my goodness. Okay, 3. Great. So those are the points. Let's see. Number 98. Is this linear or non-linear? We don't have to draw it out. I mean, you could type it into your calculator if you have a graphing calculator, or you could sketch it out, or we can just glance at it and look at it. So here's the thing. Linear, it kind of looks like it's linear, right? Because there's a 1 right here. But keep in mind, if it has like a little 2, an exponent, or if it's a fraction inside, or if it's 2 numbers or variables being multiplied, then it's going to be nonlinear. It looks like I do have a fraction, so this is in fact nonlinear. So we know it's not going to look like a straight line. It's not going to look like that. So you don't always have to type everything into a calculator or hand draw things. Sometimes you can just look at it and be able to identify if it's linear or nonlinear. I think I have a video about that. Let's see, what's the next one? 70, oh, 98, number 99. Okay, they want us to graph this. Okay, so I mean, it's just kind of like a fill in the blank thing. It's, you know, I think they used to, in my chemistry class, they called it plug and chug. So what you do is you just pick a random number. You know, you want to pick something educated, you know, like something like this. You know, you want to start in the center. right? The point of origin is what it's called. This little piece right here in the very center, it's called point of origin. You always want to start there. Ideally, you don't have to. You know, every once in a while, I guess, yeah, to strike what I said. As you get into more of the advanced courses, I noticed. Well, okay. Let's see. Should I set it up differently? I feel like we need to have a gap. Let's just do x here, and then we'll do y here. And then here is the formula they're giving me. Okay. Geez, barnacles. Okay. 9. So what do you want to plug in? Let's do -2. Let's just work this way, and we'll just go down. So we're going to have a -2 plus y equals 9. So I have to isolate it, right? So if I were to isolate moving 2 over, that gives me an 11. So let's do -1. If I had -1 plus y equals 9, and I move that over, it's going to give me a 10. What about 0? 0 plus y equals 9? Well, that just gives me 9. That was pretty easy. What if I did 1 plus y equals 9? Well, I would have to subtract, right? I have to do -1. Gives me 8. And then I have 2, which is 2 plus y equals 9, and I do -2, which gives me 7. Just by looking at this, would you say it's linear or non-linear? Remember, with linear, it's going to have an exponent of 2 or more. It's going to be a fraction, or it's going to be two numbers or variables being multiplied. It's going to be two variables being multiplied together. This, to me, looks like it's going to be linear. So let's see what happens. So now all I'm going to do is just plug everything in, right? I'm plugging in this and this, so -2 and 10, or 11, -2 and 11. It's going to be like right up here. Great. So I have -1 and +10 next. So I have -1 and then I have +10. What's next? 0 and 9. 0 and 9. And then I have 1 and 8. +1 and all the way up to 8. Then I have 2 and 7. +2 and then 7. So this is an estimation. We can keep doing more numbers. You can just go into infinity just doing all these numbers. Okay, great. So what does it look like? It looks like a straight line, so it looks like it's linear. It looks like it's linear. That's what we just graphed. Let's do the next problem. It doesn't look like it's asking for anything else. Well, it didn't even ask for linear or nonlinear. It just essentially wanted me to graph it, which I complied. Right? So, okay, here's another one. It's the exact same thing, except this time we are going to graph a different problem. Let's apply the same concept, you know, like we can do -2, +2. This is just the number line. That's where I'm getting this from. Okay, so I have y equals -2. I have y equals -2 squared plus 3. What does that give me? Well, it's going to be +4 because anytime you square root, every time you do a negative inside these parentheses, right, it's going to be positive. So I have 4 plus 3. What does that give me for y? 7. Let's do -1. So I have y equals -1 squared plus 3, which gives me 1 plus 3, which gives me 4. What about 0? Y equals 0 squared plus 3. What does that give me? This gives me straight up 3. Let's do positive 1. Y equals positive 1 plus 3. That gives me 1 plus 3, which gives me a positive 4. And should I do a line? And then I have 2. Y equals 2 squared plus 3, which is 4 plus 3, which is 7. Okay, so we're just going to draw those out. But if you look up here, the graph, if you want to guess, is it linear or is it non-linear? So with linear, it's going to just be straight up. It's going to have like x is 1. With non-linear, we're going to have a 2 or more. We're going to have a fraction, or we're going to have stuff being multiplied together. Right now, we don't have any multiplications or anything. So let's see. I'm guessing it's non-linear, right? That's what I'm leaning towards. Let's go ahead and draw and let's see what we end up with. So we're doing -2 for x and 7 for y. So -2 and 7. 8, 7. -2 and 4. 1, 2, and 3, and 4. 0 and 3. 1 and 4. 2 and 7. Does that look? Oh yeah, it does. Yeah, okay. So it looks like it goes this way. Okay, yeah, it looks like it's non-linear. So it looks like we guessed correctly. Great. Let's see if we have more. Oh yeah, looks like we do. Okay, well, it just looks like we're doing some square root stuff. Let's see. So we have this negative. This works really well, like if you have a calculator. I might use a calculator for some of these. So the square root's on the outside. So square root of 64 is 8. That's my final answer. Okay, 144, we know that's 12. We're going to simplify this. It's asking us to simplify. So, if I put this into like a calculator or whatever, it's going to give me, it's not going to be a whole number. Let me see what it says. It gives me 8.66. So that's what it's telling us to simplify. It wants me to do a different performance. So 75, we did 25 3 times. Right, so that gives me a 5 and it gives me a 3. What about this? We got this 8. What is that? Well, we just divide that in half. There's a video I have about all this on my channel. Oh wait, sorry, I wasn't paying attention. We just divide it by half. And then we rip off the hat. This little thing right here, right? This radicand. The radicand is going to be 4. We just take the exponent and divide it by half. That's all we're doing. And then we remove the hat. Same thing here. That 2 becomes a 1. That y becomes a 4. And we take off the hat. These are pretty easy. Well, rather these last two. Okay, looks like there's more. Okay, let's go ahead and do the same thing. Square root of 9 is 3. And then the 6 is 3. And then that 10 is 5. That's my final answer. Here's a 9. So we can't divide it in half. So what do? Well, we try like pulling it apart so we can go ahead and divide. What does that look like? Well, we're going to do y8. And then we're just going to keep 1 dangling, just hanging out. So that way that y8 becomes y4. And then this second part right here is just going to be square root of y. This whole entire thing is the answer. What about this third one? I have a 3. I can't divide 3. So what do? The same thing I just did for 107. So I do square root of A2 with an A being multiplied. And then I do B squared with B being multiplied. What does that leave me with? It leaves me with A square root of A times B square root of B. And I can clean it up a little bit. You know, I could move the little coefficients together, and then I could do A and B. Right? These are both like chill. They're both chill. So it just depends on what like the instructor wants, or or whatever you prefer, if they're pretty chill about that. So let's see, the square root of 27 is not, it's not a whole number, right? I don't think, let me see, 27. Yeah, I'm on my calculator. It gives me 5.19. So let's go ahead and divide it. We could probably do like a 3. Let's do a 3. Seven, 8, 9, yeah. And then I have the A is a 3, so of course I have to like pull it apart a little bit here. And that B can stay as is. So what does that leave me with? Well, I got to keep that square root 3 because I can't do much with it. That 9 becomes a 3. That A squared becomes an A. And then we have, let's cross these out as we go. And then that A becomes a square root of A. And then that B becomes a 3. Right, so that's the final answer, but let's go ahead and clean it up. We're going to move everything over. 3, A, B, and then we have the square root of 3A. Did I do that right? 3 square root. Why does it feel weird? 27, 9 and 3 is 27. Keep the 3. Let me check the answer in my book. What number is this? 109? 109. 3AB square, 3A. Yeah, it's correct. Yeah, it's correct. Why does it look funny? Interesting. Okay, well, it's saying it's correct. All right. Let's do the next one. So let's see. These two words multiplying together, right? So 18 plus 18 plus 18 gives us 36. And let me see the square root of 36. Yeah, it's 6. Great. So when there's variables, right, these little alphabets, when there's variables of which are alphabets, there's like little special rules. If there's no variables, you're just doing whatever it's telling you to do inside, which this time it's being multiplied. Yeah, it looks like, I guess these are all going to be square root stuff. So here there is, again, with no variables, so it's just going to tell us what to do inside. The radicand is telling us to add 29. Can't do anything with that, so let's just keep it there. 29, 27, no, 9, 11. Yeah, I don't think there's anything we can do with that. Okay, so this has the same base. This 112, it has the same base. So we're just going to add the coefficients. The things underneath underlined are the coefficients. So it's 7 plus 3, and then we have the square root of 5 down over here on the second side. So what does that mean? It's going to be 10 square root of 5. What about the next one? 60, 15. Those are two different bases. So I'm going to try to get the same base by messing with 16. I mean 60 by messing with 60. Let's see. So let's try to see 15. Yeah, let's do 15 and 4. I gotta put my calculator on for this. Okay. Kind of running out of steam here. Great. So now we can end up with the same base because we can make that into a 2. So what does that give me? It gives me 2 square root of 15 for the first part plus 2 square root of 15 for the second part. If I were to put those together, we have the same base to represent the square root of 15, and then 2 plus 2 is 4. This is my final answer. Let's do 114 next. 48, 27, it's like a 3. We could probably pull a 3 out. Okay. Let's do 3 times 9 for the 27. And then with the 48 divided by 316. Let's do 316. Okay, I think that's 4 and 3 and... Okay. Great, so we have the same base of 3. So with this first part, it's going to be square root of 3 times 3, because at 9 it becomes a 3, plus the square root of 3, and that 16 becomes a 4. Right? So 3 and 4 is 7, and we keep the base as is. That's our final answer right here. Right? So I wonder if I could have done that backwards so it's more visually appealing. It's easier to digest. So let's see. 15, 10, 6, it's like a 2. Oh, wait. It's being multiplied. Ah, see, that's how they get you. Okay. It's being multiplied. So it gives me a 60. Great. So let's see. I can't really do much with 60. But maybe I can... 10, 6. We can't do that. Three and 20, we can't really do much with that either. Let's do 4 and 15. I guess that could be, okay, so then that 4 becomes a 2. Yeah. Hopefully that's right. So we almost did something different, but it's asking us to multiply. When you're multiplying, you just do whatever it's asking. With the addition and subtraction stuff that we were doing up here, you got to make sure the base is the same. We had to manipulate and to find the base with these problems, right? So be very mindful of the operator, the plus minus division sign. Like when you do a lot of problems, you're going to you get overwhelmed. You maybe get bored and stuff like that, Let's see. There's a few more. I think this is the last page. Number 16, the font's really small. So it's asking us to multiply, so we're going to multiply everything together, and we're following the same rule. Right, so let's see. I have x right here becomes 5. Then that y becomes a 2. And that z just stays z. Let's see. But of course, I gotta make sure that I break it down further. So what do? I'm going to make that x into a 4 and then keep it an x here. That y is chill. He could do whatever he wants to. And that z, I can't really do much. I have to keep it as is. So what does that give me? It turns this into just x squared. Wait, is that right? Yeah. but then I have to keep the x, the y, and the z as is. Wait. Oh my gosh. No, I messed up. Let's semi-start that back over. So the x became 4, and then here's our fifth one. The y is a square, which we can work with. The z remains as is. Therefore, without error, ideally, we're going to have x2. Then we're going to keep that x as is. That y is just going to hang out as a 1, and then that z is going to be square root. Thus giving us this as our final answer. 2x, yeah. Okay, I'm completely losing confidence. I hope these are all right. Wouldn't that be hilarious if they're all wrong and I'm just like submitting this to you guys? Okay. Let's see. Here's another problem. Okay. 32 and then 2. It's hard to see this. Let's do 64. We're following the same formula up here with the variables, so that gives me x4. What does that give me for y? 3. Cool. So let's see. Yeah, so now I'm going to have 64 x4, and that y I have to break down further. Right, so it gives me 3 right there. That 64 becomes 8. That x becomes 2. That y becomes 1. And then this one stays square root. This is my final answer. With this one, okay, I don't have the same base. I almost do. Right, so let's see. Oh wait, we're being multiplied. So, okay, I guess it doesn't matter. So we have 12 for the coefficients, and then 6 and 3 is 18. Is it 18? Let me check. Oh, I'm like so exhausted. Okay, yeah. Okay, right, we got it right. All right. Let's see, I can't do anything with 18. Maybe like 8, 9. Yeah, let's do a 9. 2. Right? Because we could do that, 12, and then that 9 becomes a 3, and then that 2 stays square rooted. Then we can multiply these two together, thus giving us 36 square root of 2. That's our final answer. Let's do 119. That's the last problem. If a and b equals this for all real numbers, a and b, what is the value of, okay. So it's saying this a and b is a plus b squared, right? As like one term. We're going to replace a and b with this. So we're going to get 5. What was it for? Is that a 4? Yeah. That's a 5, that's a 4. Right? So 5 and 4 is 9 squared. And then 9 squared is 81. Great. So it's just kind of like a wordy problem, but it's just asking you to replace a and b with 5 and 4. That's it. I mean, we technically didn't even need this. We just needed this part right here. That's it. Right? And the reason I knew how to work this is because PIMDOS. I can't stress to you enough how important PIMDOS is. You're going to use it like for every class. right? So I did the parentheses first, and then I did exponent second. That's why I put 5 and 4 together. Okay, so that's the entire review. I don't have any more questions, so if you guys, I don't know, have questions? I don't know. Okay, so that's it. That's the algebra review. Okay, thanks everybody. Goodbye.